Hello, everyone, and welcome to the 37th episode of the Startup Boston Podcast, where I interview entrepreneurs, investors, and influencers in the Boston startup community to uncover actionable advice and stories from their experiences. I'm your host, Nick Dupuy. Today's guest is David Smith, CEO of LiquiGlide. You might also have seen their YouTube videos with the ketchup pouring effortlessly out of the bottle. LiquiGlide's technology was developed at a research lab at MIT and develops permanently wet, slippery surfaces that can be used in a wide range of applications, from manufacturing to consumer packaging to oil and gas. In this episode, a few things David talks about are the amount of waste we produce every year from product that is being left sticking to surfaces, who some of his mentors are and what he's learned from them, how the coatings differ depending on the product, and the potential uses he sees having the largest impact. If you like today's episode, be sure to subscribe to the podcast on iTunes so you get all of the new episodes as soon as they're released right on your podcast app. And as always, you can find today's show notes at startupbostonpodcast.com, and you can reach me at nic@startupbostonpodcast.com. Enjoy today's episode. Dave Smith, thank you so much for coming on the show today.
You're welcome. Thanks for having me.
I first saw the video with the ketchup like 4 or 5 years ago now, I think when it was first released, and it was really exciting. I think a lot of people were really excited about it. So then when I was given the opportunity to interview you guys, I said, this is going to be really cool. Excited to be here. To get us started, can you tell us a little bit about your background and who you are?
I'm Dave Smith. I'm CEO, co-founder, and co-inventor of the technology. I'm a mechanical engineer. I went to MIT for my master's degree in mechanical engineering. I joined a group of Varanasi's lab, and we invented this technology, liquid impregnated surfaces. Saw a huge potential for it and started a company.
How did you get involved in the research group?
I joined Kripa's lab because I was interested in microengineering, nanoengineering, and surface technologies. He was right at the intersection of those fields and many others, and I interviewed with a few different professors at MIT. Was most excited with what Kripa was doing and his vision for making a real impact with the research he was doing.
So tell us more about LiquiGlide and how the technology works.
LiquiGlide is a spin out of MIT. It was founded to commercialize liquid impregnated surface technology. So liquid impregnated surface technology is an idea Kripa and I came up with. Generally, the way it works is a lot like if you put like oil on a frying pan. You know, that it's a slippery surface that's wet, but it's only temporary. The liquid wears off the surface, and then stuff will start to stick to the pan. Well, we make that type of lubrication permanent by trapping the liquid in place through strong capillary forces on the surface.
Now, were you intending to start a business off of this research, or is that something that just kind of unfolded due to the outpouring of kind of responses you got from it?
I could say we spent a lot of time trying to figure out if this was an idea that we could build a business around. Pretty fast that we realized we could. Really, it was primarily having some fundamental breakthroughs in the technology that convinced us that this is something that could work very broadly.
And tell me about how the coatings differ between the surfaces that they're being used on, right? Because from what I read or the research I did, the coatings you use for food products are different than what you use for oil and gas, is different than what you use, say, for paint. So you tell me how they differ and why they differ?
Sure. There's several reasons why they differ. First of all, a slippery liquid impregnated surface requires careful selection of the materials for the particular application. So you won't even have slipperiness with one coating for one product and for certain other ones. Like the coating for mayonnaise does not allow paints to slide, and the coating for paints doesn't enable mayonnaise to slide. But furthermore, we also have to satisfy different safety and regulatory requirements. So our coatings for mayonnaise and toothpaste and other condiments are made from food ingredients. We've pulled a lot of the materials we work with from all the materials we work with for foods are from the FDA GRAS lists and food additives lists. But in cosmetic applications, we build coatings from materials that are already approved or already cosmetic ingredients. And we have different requirements that we have to meet for every application.
So tell me about the importance of having, this permanently slippery surface, and kind of like how much waste there is now because there's a lot of product that's wasted, say for food products, for example, because you can't get all of it out of the bottle.
Very generally, what our coatings do is they overcome a fundamental challenge that viscous liquids stick to solid surfaces. That causes inefficiencies and waste in every single industry. Packaging is one of them that most people are familiar with from our videos. And in that case, we estimate that there's at least 2 million tons of viscous products stuck in packages every year that gets thrown away. So it's just wasted material. So we could eliminate all of that. Furthermore, there's millions of tons of material that gets wasted in manufacturing of viscous materials in tanks. So everything that gets stuck in the package is also mixed up in a tank somewhere. And there's waste from the material sticking to the tanks. And there's also wash water that has to be disposed of, which adds to costs, and it's another waste stream. I mean, those are just a couple examples, but the potential for the technology is huge as far as waste reduction goes.
So are producers worried at all that consumers would be buying less of their product when it's in packaging, or do they like it because it improves their customers' experience because they're getting all of the liquid out rather than just 98% of it or something like that?
So that really hasn't, the first point really hasn't been a concern that consumers are able to get all of it out. It's far more important for consumer brands to improve their customers' experience. They've actually never been concerned about the idea that consumers get a little more out of each package because it's far outweighed by the ability to increase market share or to charge price premiums because they know their customers will pay for this.
Okay. Now the company, was that founded in, was it 2012? Or was that when the research was?
The company was founded summer 2012.
Okay.
We moved into our labs in 2013.
Okay. Let's see. So your first customer you signed in 2015?
So we had paying customers for development projects and feasibility studies in 2013.
Okay. So tell me about what it took to go from discovering the product to then getting paying customers for the product.
First, the challenge is really deciding where to focus. We had thousands of companies, literally thousands of companies reaching out to us within months of our initial press outbreak. Mm-hmm. So we met with probably 100 plus of these companies and were able to narrow down to those that were willing to fund the initial research and development. And those studies helped us narrow in further on which applications are going to be the quickest wins with the biggest impact in the market. Mm-hmm. So that took a lot of time, as there were a lot of different routes that we could go for this. Because we had so much interest, we were at least able to do this and know that we're starting off on places that are going to be really big successes.
So what were some of the original uses for the product?
Original uses for the products, only toothpaste packaging. You can go from a laminate squeeze tube to PET bottles that empty out completely and easily. Also, mayonnaise. Mayonnaise can be fully evacuated easily from PET squeeze bottles. And there's also no-clog glue caps and other adhesives we can prevent from clogging the caps. Also can allow those adhesives to completely evacuate from their packages. Lotion packages, conditioners, these can now fully evacuate easily and completely.
So there's a lot of different potential uses for LiquiGlide, both from consumer products to oil and gas and medical. Which ones do you see as having the largest impact?
It's hard to say, as we're still we're always learning more about economics of eliminating waste in different markets. Certainly, the ones where we have the most data are in consumer packaging and also in manufacturing applications, where we can prevent materials from sticking to the insides of tanks and eliminating yield losses and wash water costs and also increasing utilization of those tanks. You can do more batches a day if you don't have to clean in between the batches. As there's so many viscous products that are in containers and also mixed in tanks, both of these end up being huge opportunities for the technology. That being said, there's so much that we still have to learn about applications in oil and gas, medical devices, pharmaceuticals. For all we know, those opportunities could end up being at least as large as what we have in consumer packaging manufacturing, maybe much larger.
Mm-hmm. Were there, after you discovered the technology, was there any use cases that you found surprising that maybe you never would have thought that it could be applied to that field or those products?
Yeah, I mean, there's certainly new use cases all the time that we're learning about. For example, like things like you could put this on the inside of molds for ice cream popsicles and allow them to release. You don't have to heat them up enough. Yeah. Right now, you have to heat the molds up just above freezing so that you can separate them.
Okay.
So with the LiquiGlide coating, you wouldn't have to do this. We haven't found a particular customer for this that on its own is big enough to justify focusing on it at the moment. Mm-hmm. But there's lots of small things like that we just wouldn't have thought of applying the technology to. But I'd say those kinds of things that we wouldn't have thought of probably make up like 80% of all the applications we hear about.
Wow. Now, to use it in food products, did you have to get FDA approval? And what was that process like?
We have some coatings that don't need any further approval for food applications. We always start with materials from the GRAS database and food additives lists, FDA food additives and GRAS databases. But those materials, although they can be approved as ingredients in foods, they usually need separate approval to be used as a coating. It's a straightforward, fast process, but as we use different coatings for different materials, in each case, once we have a customer that wants to launch it, we go through that approval process with them.
Okay. Now, what was it like for you because you left your graduate school, right, to become CEO of this company. So what was that like for you to leave graduate school to become CEO of LiquiGlide?
At first, it was a bit overwhelming because we had hundreds, really thousands of companies reaching out to us interested in Glide, and it was didn't know how to handle all of it, but quickly found some really capable mentors, business people, to help me figure out a way to get on top of all of this, to help me find really talented entrepreneurs to bring into the team. But once we ended up having the resources to help execute all of this, it did feel like this feels like more problems to solve. Like in graduate school, you're just solving problems. Maybe they're highly scientific problems or technical problems, and going to a business that shifts to more business and technical problems. But it's still you approach every problem with the same sort of problem. What ways of critical thinking? You approach them very scientifically. You're doing research, testing hypotheses, and adjusting your hypotheses based on what you're learning. So it's in a way, there's a lot of similarity.
Who have been some of your mentors, and what have you learned from them?
So I think some of my most influential mentors have been Professor Kripa Varanasi. First of all, he's been someone who I see as capable at really solving any kind of problem. He's not limited by what his specific experience is. He approaches every problem for what it is and just tries to come up with the best answer. And I quickly engaged with him in solving lots of problems together, and it increased my confidence in that also. So he's definitely given me a lot of confidence in what can be accomplished just by being a great problem solver. Colin Gounden is someone who he's on our board and one of the first non-founders to work with us. He's a seasoned, successful entrepreneur. He's built companies to 1,000 people. Also gave me a lot of confidence in myself from someone who's built companies before. He was impressed with the planning that we had done to date, the work we had done with customers before he even got started. Assured me, we're on the right path. If we're stressed about these about handling all of these things, there's people that can help you with that, and I'll help you find those people. And he's always been helpful, like when we run into new types of challenges before, and it also helped me realize the value of mentors. So I've greatly expanded my network of mentors and advisors since then. What
would you say was the largest mistake that you've made with LiquiGlide, and what have you learned from that?
I think largest mistake I made with Glide was being over optimistic on the timelines. Ends up being the customers that we're most focused on are massive companies with large brands where they want to do something really big with LiquiGlide. But that takes a lot of time, a lot of market research. And, I'd heard this, but thought we'd be able to get creative and figure out how to help find a faster path with them.
Yeah. And
given the huge amount of excitement, I assume that would drive them to work outside of their normal processes. Found it hasn't been as easy to influence their approach to commercializing technologies as we thought, and it takes a lot longer. And had we known that, we would have certainly planned better around those timescales.
What's been the most difficult part of growing LiquiGlide?
Certainly been it's been a challenge. It's all been about identifying as quickly as possible where the fastest and most impactful paths to market are. Mm-hmm. And then not being distracted by a million others that keep coming at you, because everything sounds like more exciting. Everything that you don't know much about sounds amazing compared to things where you've seen all the hurdles, all the challenges that you have to overcome.
Yeah.
And so it's always tempting to explore all these new ones. And we still do explore them, but we're much better now at quickly figuring out if there's something worthwhile compared to what we're already spending on our time on.
What does the future look like for LiquiGlide, and what are you most excited about?
Someday LiquiGlide is going to be ubiquitous. You're going to see it in just about every package of viscous products, conditioners, shampoos, mayonnaise, ketchup, every condiment, cosmetics, paints, adhesives, pretty much there's products all over the place that stick to packages, and we kind of assume that this is the way it's always going to be. But we'll also be in just about every factory somewhere that's making anything, because there's viscous liquids everywhere and inefficiencies as a result. We'll be all over the oil and gas industry, medical devices. Basically, we've changed a fundamental constraint that viscous liquids, until LiquiGlide viscous liquids stick to solid surfaces. We found a way to overcome that so it can completely change a way a lot of systems are designed, products are designed. So say the thing that I'm most excited about there, I have to say, is packaging, because it's not that the actual impact, the direct impact in packaging is any larger than what it is in manufacturing or oil and gas medical devices, but it's that we'll put the technology in everyone's hand. I expect someday, and not very long from now, LiquiGlide's going to be in the hands of just about every engineer in the world. And imagine there's going to be a lot of ideas that will really start to appreciate how the technology works and how it might apply to challenges that they're facing.
What I understand sets your product apart from other products is that your product doesn't wear down, right? So it always remains permanently slippery, like you said, rather than becoming less effective in the future. Right?
That's right. So liquid impregnated surfaces are self-healing. Like if you scratch the surface, the liquid will move in and replace liquid. You can't scratch a liquid surface. Mm-hmm. That being said, you do have to, we have to custom design around certain requirements. So in the case of pipes, for example, you do have to replenish the liquid in the coating in very small amounts, and that's a way of keeping the liquid permanently wet. Anything that's pulled away can be wicked back into the textured surface the same way water wicks into a tissue.
Okay.
And you can supply that continuously, so you never even have to stop running stuff through the pipe to be able to replenish the coating.
Wow.
So in that way, it becomes a permanent approach to allowing viscous liquids to slide on solid surfaces. In packaging, we don't need to do any of this replenishment. We have coatings that can survive throughout the whole use package.
I want to move now into our rapid fire questions. So the first one is, what's another startup in Boston that you're most excited about?
DropWise Technologies.
What do they do?
They're another coatings company out of Kripa's lab that we've collaborated with. They make solid surface coatings. You can give, are highly durable, can work for just about every surface. One of their main applications is allowing a highly efficient form of heat transfer, DropWise condensation, which can replace filmwise condensation, which is what's currently used in just about every steam turbine world. So the improvement in efficiency that they can create by going from filmwise condensation to DropWise condensation can be transformational and applied across every system, every steam turbine in the world.
What's something about you that most people don't know?
I now have a 4-month-old daughter.
Oh, well, congratulations. It's very recent.
Yes. Thank you.
What advice would you give to your 20-year-old self?
Start getting to know people that you want to work with. You're going to want to bring people on your team that you really get along with well, and that you communicate well with, and that you also respect.
What's your favorite condiment?
Ketchup.
Ketchup. Outside of work, what do you look forward to the most?
Seeing my 4-month-old daughter when I get home.
What are some of your favorite tools that help make your life and work easier?
So I like to listen to audiobooks. Find Audible really useful. Mm-hmm. Always when I'm traveling to and from work, able to get through a lot of books.
So what are some of your favorite blogs or books?
So a few that I've read recently that I really liked. 0 to 1.
Peter Thiel.
Yep. There's The Originals. It's a book about what makes innovators.
Yep.
7 Habits of Highly Effective People. It's another great one.
Mm-hmm.
Another one I really liked. It can help engineers to start thinking about business scientifically, how to measure anything.
Okay. What's that about?
It helps you. It's a way of looking at things that would seem subjective or decisions that you have to make that are subjective, and actually looking at them quantitatively. So you can talk about uncertainties in terms of confidence intervals, and you calibrate your confidence intervals so that you can actually use that. It's a language you can learn within the company, and a lot of people at LiquiGlide now kind of speak this, can talk quantitatively about business decisions.
Just a few final questions here to close out. So where can people find out more about LiquiGlide?
LiquiGlide.com.
And where can people connect with you online?
My LinkedIn profile.
And do you have any parting thoughts, advice, or suggestions for the audience?
I would say if you have an idea and you want to start a company, don't talk yourself out of it. There's always a statistic that 9 in 10 startups fail. But if you have the opportunity to do it, why not do it? If you fail, probably be able to get another job. So I don't know why everyone talks themselves out of it. And if anything, it might help you get a better job, and it'll give you a much different perspective on how to work. I think you'll learn so much. It'll make you far more valuable in anything you do after. Lastly, I want to say we're always looking for people, for highly entrepreneurial people, to join LiquiGlide. We're currently hiring. We're looking for entrepreneurial business people, salespeople, and engineers. We look for people that are also extremely talented, of course, and up for a challenge of a startup.
Fantastic. Dave, thank you so much for coming on the show today. It's been a pleasure.
Thank you.
If you liked today's episode, be sure to subscribe to the podcast on iTunes. You'll get all my new episodes as soon as they're released right on your podcast app. And if you really liked today's episode, it would mean a lot to me if you could write a review of the podcast as well. Just go to startupbostonpodcast.com/iTunes. And remember, you can find all show notes with links at startupbostonpodcast.com. Until next time, if you have any feedback, ideas for guests, or just want to say hi, you can reach me at nic@startupbostonpodcast.com. Or reach out on Twitter at startupbosscast. That's startup BOS cast. Cheers.